This is a chart for an older software device.
You don't have, if you have funding, it almost hits.
We put like a projective screen.
We already have
projective
funding,
screen,
so we're pretty far
along.
So I think our bubble would have less of an impact, one would hope.
When we had only 8 employees, we filmed this.
What were you using for the screen?
It's also
This is
difficult to
semi-transparent.
find more talented people.
Yeah.
We're always hiring.
And then,
Did you upload this video to YouTube?
Okay,
no, we haven't
It's
shared this one.
private.
I'm gonna bug you on Monday to get one to get play with one.
This is another one this is really an example of the direction we want to take the technology, and this is a very more advanced data visualization. What some scientist manipulating a high-dimensional data set would want to do. And the company was once called OcuSpec before we chose the motion.
I didn't even know another crazy number.
So this is also overlaid on the screen. You can see that this is the data coming out of our device.
No, we did this long time ago.
That's rough.
And see, there's like a network of 3D data that you can manipulate. He's just grabbing and squeezing in.
Well, there's
Pushing it around
a
like
version of this on our first trailer, right?
The database.
Very, very basic.
Yeah. So one that's less complex.
It's a very direct physical interaction with the data. You don't have to rotate, move a mouse with something.
How old is this video?
Show me how it works.
Sure. Let me plug it in and get started.
But why don't you sit on this side so that they have enough space to walk around?
Thank you.
Have a seat.
Thank you.
I ordered 3 on the first day for myself. And every time you made an announcement for delay, I feel.
Very sad, huh?
Very sad.
So this is our data visualization. It's really an internal tool that we wrote for ourselves so we can see how it works. And to orient you to the space, I'll first show you a couple of things. We have the 3 different axes here. This is a 3D space. You can see along the right side here, the red axis is X. Here we have Y and Z. Totally 3-dimensional. It's just like a mathematical plot of X and Y, and then you also have the Z dimension, the depth from the screen. And this triangular, this pyramidal shape coming out of the base is the view frustum. That means it's the field of view, what the device can see. So things that are inside this, let me rotate around a little bit so you can get an idea. Things that are inside this pyramid, we can see from the device, and anything else, it's out of the field of view. So if you put your hand in, you can see that we can track 5 fingers, and there's very, very low latency. It's a very immediate response. And if I point one finger, you can see I get not only the position of my finger, but the direction as well.
Yeah, it's amazing.
Right? Point 2. And we even have information about the hand itself. So this is a palm plane.
It's so natural.
Right? It's the direction that the hand is facing. And this little vector coming out of the bottom is the direction towards the palm. And this lets you do many different interesting things. Not only you can use the finger's absolute position, we also have the width and length of fingertips. So you can see my 4 fingers over here are a little bit skinnier than this one on the left side. My thumb is a little fatter, and this one's shorter, right, than the rest. It's a little skippy right now, I think, because of the lights.
Right.
In addition to this, we can actually represent where is the screen in relation to the device. So here is a representation of that in our visualizer. You can see it's back behind this grid over here. I can go like this and turn the grid off so you can see it a little bit better. So this is a representation of where that screen will be, and I can point my finger and project it onto that screen. So I'm actually getting the coordinates of where I'm putting my finger right onto the screen. So I pointed the lower left corner, upper right, and this works for any size screen at all. It could go from a small monitor like this or a tablet up to a wall, a projector. It doesn't matter.
You are cyborg. Great.
We have a little tool that lets you find where is that screen in relation to the device. So it lets you project your fingertips on like this, and we'll find the closest point to what you're pointing to. You can see right over here, one of my fingers pointed off to the edge, but we jumped onto the edge, so you can see that's the closest point. There's also a gestural interaction, so let me show you that next. Get this off. Get you back oriented to the space. There's a couple different types of gestures. You can do a swipe, which is like a left or right or up or down. It's some sort of straight motion. It really can be in any direction and will detect one per finger, like this. And this might be useful for if you're doing a photo application, you want to switch to the next photo or a slide or something like that. Maybe you're playing a Tetris game and you want to drop the block down to the bottom. You can do it that sort of a motion. Another one we can do is a circle. And so this actually represents my my finger in 3 space. It's showing I'm doing a circle that's flat against the table. And because this arrow here, let me zoom in a little bit. It's a little choppy because of the lights. This arrow is pointing down. That lets me know it's a clockwise circle. And if I go backwards, the arrow will be pointing up. So we can detect it really in any dimension. And we'll keep updating it as it keeps going along. And again, it's per finger, so there's multiple circles you could do. There's a few other gestures. One's called key tap, and it's if I tap down towards the keyboard like this, you'll see that there's a little... Oh, that's much better. There's a little drop at the bottom, and that shows the moment of impact when I did the tap, right? And if I tap towards the screen, you can see that's exactly where the taps occurred. So tap down, you can see, there we go. You can show these little taps here. And this can be used for a lot of different things. You can have some sort of application where maybe there's a button and you poke at the screen to tap it to select. We also do recognize tools. If you use a pen, a chopstick, a drumstick, something like that. And you can do a drumming application, and the taps at the bottom represent when you're hitting the drums. Or keyboard taps like that with your fingers. But
Music.
this is actually not an application. This is just a data visualizer that shows what kind of information is exposed from our device and through our API, the programming interface. But I can show you something more interesting. We have a couple of demo applications that we built ourselves.
Oh, great.
So this one is really fun. I think it would be perfect for a museum or something. Let me turn the brightness up a bit. So this is a bunch of fish forming a school. They're flocking around each other, right? If I put my finger in, I make a little glow ball, and the fish are attracted to it. They think it's food. They surround it, and if I put my whole hand in, they're attracted to all of them. But if I shake my hand quickly, they run away. They're afraid of it, you know? And I could even maybe shake these fingers quickly to get them afraid of these, but they're attracted to my thumb. You can mess around. You can scare them with this hand and attract them with the other. It's a fun little application that, you know, a child could easily play with and have a lot of fun. It requires no learning curve. You know, you just put your hands in and immediately can see what's happening.
Like a Star Wars.
Yeah, that's just a little fun one. We have a gestures demo, which is another just example of what you can do with the gestures I showed you. These are like little particle tadpole things swarming around with these nice little glow effects. And if I do the swipe gestures, I can move them all at once in any direction, right? If I make little circles, I can make them swirl. And you notice I'm swirling here in the bottom of the field of view. If I swirl up here, I can make these swirl. And then if I do a screen tap like this, they'll run away from me because I'm stabbing at them. But if I do a key tap like this, they'll gather together. So it's just another little fun thing to play with. This is just an example. It's an open source example we built to say this is one possible idea of what you can do. Hopefully people will take this much further. We also have a JavaScript API which lets you run applications in the browser. And here's one example I'll show you. This is a, let's see. This is an Earth example. I can rotate around. I can spin the globe around by moving my hand left or right. I can change my elevation, my angle of inclination towards the globe, and I can even zoom in and out by pulling in all directions. And I can control all of these simultaneously. So if I wanted to do a flyover into San Francisco, I can go whoosh, up like that, right? And this is again an open source example we built. It literally the code to run this is about 15 lines of code to manipulate the camera based on the leap motion input. Whereas the Google Earth team actually integrated leap motion directly into their application, and it's much more advanced controls. You fly your hand around like an airplane, and you can zoom in and out and swim around. It's really, once you get to know the interface in a minute or two, you can do a whole flyover tour like you're driving a helicopter, and it's a lot of fun. Maybe I'll show you one other example. Oh, I'll show ink motion. So this is an application built to model like a pen input. Even though we've given devices to Corel, and they're putting in Corel Painter so that you can do natural motions. You can pick up a paintbrush in the air and stroke it. And I think we're actually in the middle of producing a video that shows how that application works. But this is one that somebody wrote in the browser. If you have this device, you can visit this website and immediately start using it. And it takes just a moment of calibration to know where the screen is. You put your finger here, nearby. Demos never work flawlessly. Come on.
Come on. Great.
Does that sensor work? How many inches should
So it has a pretty large range, like this, and up to about maybe 2 feet away. Okay, let's see if I can get it to work. So
great.
here we go. Once it knows where the screen is, now I can actually paint. So I can write words. Hello.
Hello.
Right? And you can easily, this is an application built in just a couple of days. You can add many features to this: colors, textures, images. I think he even allowed you to put a space theme, and now you can write with, oh, it's black. That's probably not a good one for this. So now you can see the text. You can change the background around. You can do all sorts of things with it. Now I'm writing with kind of a whitish color on top. This is just a lot of these are examples that these devices are only going out to developers in the past 6 months, and there's so many great ideas out there that people are just now beginning to build. So I think that the future looks really bright. What people can build with this is really incredible, and have natural interactions. I'd also like maybe we could get Paul Hung in his physics demo. He, one of our other engineers at Leap Motion, he's been building a lot of example apps, and he's really into physics-based interactions. It's just perfect for this device because it lets you reach in and actually grab something. Last summer we had an intern, and one of the demos he built is a Jenga game, which is the tower blocks you pack up. And you can pick up the brick and stack it on top. It's total physics interaction.